Assalamu alaikum, ladies and gentlemen. Welcome back to another live stream. Let's go. So we're continuing our scripting language using parser combinators in Rust. This is part 2, so please watch the previous part if you haven't already. Okay, and also I have actually published this project into GitHub. There you go. You can find the commit hopefully in the description or the comment section after this stream, or I could put it on, you can just find it in my Discord. I have already published it. And actually let me, okay, there you go. Okay, let's go. Alrighty, where's my chat? Okay, cool. And let's grab this and grab this. Okay, great. All right, so this is what we had. So hello Theo Paris, welcome to the live stream. How is it going? Okay, so last live stream what we got is some simple parser going on right now. We got numbers, identifiers, let. We even tried to evaluate, but that didn't go too well. I was tired at that point. So honestly, I think what I'm gonna do, I'm gonna focus on parsing for now until later, then we can implement the evaluation, right? So for now, unfortunately, I'm just gonna remove the evaluation part and let's just focus on one thing at a time. So there you go. Parser.parse source assert in wrap print line ast. Okay, great. Sources. So we're not using the evaluator in this case. Good. Cargo R. And yeah, this is what we get for this little code right here. Let x add number 1 with number 2, and in fact I could make this a little bit beautiful by adding a hashtag here. Just simply. And let's go. So this is the tree, the AST that we're getting for this code. Let x add number 1, number 2, and we can actually add multiple let blocks right now. The new lines, I don't think they matter. Yeah, they don't. There you go. So let x add number 1, number 2, and let x again add number 1, number 2, and okay, cool. So what we were stuck in the previous stream is how to get binary operators working correctly, because while right now it does indeed work with 2 numbers or 2 expressions, it doesn't work right now with multiple, like more than 2 or just 1 essentially. So we gotta fix that right now, and I'm honestly not entirely sure about how we're gonna do this. I'm still new to Chomsky and parser combinators, but we'll see how it goes. Okay, so we have the unary operator here. We got the sum. So first of all, I don't think we need to start with the sum. We should start with the product because it have more precedence than the sum. So let's switch this to a product first of all. And so this would be multiply and this would be divide. And multiply and divide here. There you go. Okay, we don't have divide. Cool. Okay. Let's remove add and sub for now, and let's just go with divide. Box expression src, blah blah. Let's go. And there you go. Cool. OBS disconnected. Okay, I think OBS have reconnected now. Can you please confirm if someone is watching, if OBS is good now? Okay, anyways, so product is equal to unary operator, then x, then unary operator dot map LHS operation RHS operation. And honestly, I think we have done it a bit too soon, maybe. But let's see what we got here. So how are we gonna do this? Unary operator, then x, then unary operator dot map. I see. We can see some example of Chomsky for this. We can see some example. Here we go. So here's an example of Chomsky. This is foo.rs, which is a simple language right here. And let's try to hopefully inspire from this, I guess. Let's see the product. Okay, so we got the unary operator, cool. Dot fold L. I mean, sure, let's redo it. Let product is equal to the unary operator dot fold L. But the weird thing right here is that we have one element right here, but this guy takes two. So the problem with Chomsky examples, they're kind of outdated because the Chomsky is getting evolved real quick right now because it's getting released soon, the first release, I think. So they're changing a lot, and the examples and the documentation is still a bit off. But let's try to figure this out ourselves, I guess. So let's fold the output of parser into a single value. Okay, alright, so there is a little example here. Maybe it's more updated. Interesting. So you got the integer, then fold L. Okay, so this seems to be good actually. This seems to be updated. So we got the unary operator, fold, so integer just plus dot ignore, then int dot repeated just plus. So here where we put the x, right? I guess. Oh, did we remove the x? I think we removed it maybe. Oh, actually it's here. Okay, good. It's actually here. Alright, so what's next? Ignore, then repeat it. So this is how it's implemented. So what's wrong with this? Oh crap. What? Alright. We're gonna have some fun time today. Alright. Fold L. X. A. B. It doesn't give me the type, which suck. Closure is expected to take two arguments, but it takes one argument. I'm giving it two arguments though. But maybe it's talking about this closure right here. Probably. What's up now? Trait bound choice to just char. Full name for the type has been written to. Well, I guess let's just start simple then. Let's just implement only multiply, I guess. So how they have done it again? Just plus ignore then int dot repeated. Hello hats, welcome to live stream. How's it going? How's your Vulkan renderer going? That thing you have made about the Vulkan foliage rendering, that was nice, pretty cool, using GPU instancing. I've seen that blog. So let's sum equal to int clone fold L, and Ramadan Kareem to you too, thanks. Fold L just plus dot ignore then int dot repeated. I mean, I still have this here, right? Didn't I just copied it? Didn't I just copied it? Interesting. Well, let's copy this guy. Okay. We have a lot of comments today. Cannot find value x in this scope, sure. So what we have in the example, just plus. In our case, it's going to be multiply. So just multiply, and it's saying ignore, then in our case, it's going to be the unary operator dot repeated, right? And cannot add expression to expression. Interesting, makes sense. So here we're actually going to return expression multiply. Expression multiply A and B, I guess. What are we doing right now? We have the lexer already. So we're using parser combinators. We have the lexer and the parser in the same place. Though we can actually split it later, but I'm just trying to keep it as simple as possible for now because we're just starting out, pretty much. I'm still not that experienced with the parsers, with the, you know, functional parser combinators. And these errors are like, you know, C++ template errors. Well, maybe, I don't know. I mean, there is a way to go about this, is by boxing those operators. But I don't know if that would help us, actually. IDK. Still not very experienced with this, so I'm still learning. Anyway, so what's up right now? What's up with this? Oh, we gotta box these. We gotta box these. I wonder if we can actually avoid these allocations. Well, I guess we can find out later. And there you go. At least we have something that, you know, at least that doesn't give errors, I guess. I'm sure 1 year and Rust will be the same place as C++. Hopefully. We're gonna wait until eternity for us to replace C++ and for Zig to replace C. So unary operator fold L, ignore then unary operator repeated A, B. Okay, I guess let's try this out. Yeah, sure. Let's try this out and see if this works or not. And why it's not giving error for some. I mean, I'm pretty sure I've commented that out. What? Restart the server, please. Okay. It's loading. Okay. Alright. Oh, I see, because this is an argument. Yeah, my bad. My bad, gotcha. Alright, let's try now. I wonder if this is actually what it takes to do this. Well, first of all, yeah, let's, we don't have sum yet. We're gonna start with product. Yep, sure. Let's go with this. Okay, we're getting an AST. Good sign. And let's see if we got this right or not. So we got let x, you know, is multiply number 1. So multiply number 1 with number 2. Okay, nice. And that multiply that result of this expression with number 3. We're getting it. Let's go. Let's go. We can also, instead of the number, we can make, you know, some identifier, and there you go. So number 1 times identifier y times number 3. It works. Let's go. It works. Let's make sure everything still works correctly. There you go. That works too. We should probably though do some, like, separate these parsers. So the nice thing about parser combinators too that I didn't mention in the last stream is the fact that you can make a parser into its own little parser, and then you could basically make some unit tests for every little parser, you know, separately, independently. That's the joy of functional programming. So yeah, that's pretty cool. Okay, so we got that working great, and I think I could probably figure out the sum myself. And we get precedence for free with this. So sum. Okay, and this, instead of inner operator, now we're gonna use product, and instead of mul we're gonna use sum, right? Well, sum or add. I guess we're gonna go with add actually, and add and sub. There you go. Add. Did we hold on a second? No, hold on. I still haven't handled division though. What is the R hash? Is it like escape keyword? Exactly, yeah. Because in Rust, you know, let is a keyword. So if you do something like this, it wouldn't work. But if you do R hash, then it would escape it pretty much. So we can use it. So yeah. So we can use a keyword as an identifier as long as you prefix it with this R thing here. Okay, cool. Cool. So now I actually wanna, before we do the sum and stuff, I wanna figure out how we can hopefully make this work with division too. With division too. Let's see. Yeah, we could do the same strategy that we have done earlier with the inner operator, I guess. Maybe. Interesting. So just that, ignore then. Okay, we actually don't want to ignore though the operator. Yeah, we don't want to ignore the operator. So here's the thing, I think. This is our binary operator, right? Okay. Just that binary. Oh crap. Operator? Okay, interesting. So just that dot 2, and we actually going to convert that operator into an actual closure. So we're gonna convert it into A times B, and I'm actually gonna wrap this in parentheses because I want to actually downcast it to a simple function pointer, right? Because every closure have its own type, and since I'm going to add another closure with this, or another closure, it's not gonna work because they're gonna have separate output types, which wouldn't work. So I'm downcasting this to a simple function pointer instead of an actual closure. So that would work. Okay. Here though, actually let's say expression multiply. Yeah, let's go. Expression multiply A and B. And I think I do need the boxing, right? Well, not the sport. I honestly do not know why they called it box. It's kind of weird. A box is kind of like just, you know, like new in C++ and malloc in C. So you just allocate something in the heap. So Yeah, and we're actually using boxes because otherwise it wouldn't work, you know, because we have like expression is defined recursively as expression again, and if you don't box it, then it would be infinite size, which isn't possible, of course. So we box it, so instead of storing the expression itself inside the struct itself, we actually just store the pointer to it. PTR makes more sense. Yeah, something like that. Or allocation maybe, or I don't know. Honestly, I don't know what the name would be, but box, I don't think it's a good idea. I don't know. Anyways, I guess if you make a language, you make the decisions. And we're making one right now. All right, let's see. Binary operator ignored, then unary operator repeated. Product. Okay, good. And now let's actually do OR, and let's handle the division too. Okay, just divide to expression div box as binary operator. Okay, so basically if I didn't have this, as I said, it wouldn't work. There you go. Because this type is not like this type. But if we downcast it to a function pointer, it would be all good because they take the same, you know, they have the same signature, you know. So this binary operator is just like a type diff kind of. So it's fn, a function pointer basically, expression source, expression. Anyways, let's go to the next step, I guess. Right now we should be able to easily handle multiplication, division, etc. Let's see. I probably, oh, there you go. Cool. And oh, mole. Something is wrong. Something is wrong here. Oh yeah, my bad. We haven't actually used the operator itself here yet. So how we can actually do that? Well, the thing is here we're actually ignoring the binary operator, but we don't want to do that anymore because it's not hard coded. It's gonna be defined depending on, but yeah, we'll see. So now what's gonna happen is I think it would be, so this, what is this, fold L? Maybe it's gonna be something like this. I'm not sure though. I guess we'll find out. Interesting. So actually it's probably maybe this way then. There you go. Seems to be good. Okay, so OP right now is actually a function pointer. Great. So now instead of expression mole, which is hard coded, you can just say OP. And what's up? Argument to this function are incorrect. Expected enum expression found struct box expression. Do we actually need a box here again? Oh crap. Oh, I guess because we have included the box here, maybe? Hold on. Yeah, this actually takes an expression, not a box. So I think what we should actually do, we shouldn't box these right here, right? And then we could just box them here instead. Yeah, we're already doing that. And maybe I do need another box here. That's a lot of boxes, but we can try to optimize it out later on, I guess. What's up now? Argument to this are incorrect. Expected struct box expression found enum. Yo, what's up with you, bro? Interesting. Well, the thing is, honestly, why I'm doing this to myself, just say this. expression mol as binary op, I think. And maybe I would need the box after all, actually. I'm confused. I'm confusion right now. This is a lot for my small brain. We need some Haskell developer here. Expression div as binary operator, non-primitive cast. Interesting. Well, maybe I need box after all. Is that the case? Okay, I guess. If you have some problem in yours, just make it a box and your problem will go away. Anyways, let's see what we got now. To expression div as binary. Okay, that seems much better, honestly. There you go. Let's see if this works now. And okay, apparently works, I guess. There you go. It actually works. Let's go. So first of all, we do the division. No, I mean, no, the inner ones are done first, you know. So we actually do the multiplication first from left to right because we're using fold L, not fold R. So we're folding from the left. So we're doing the multiplication first of this guy with this guy. Then we're dividing the result of this with the number, with this number right here. And there you go. We got some cool operators going on. Nice. Nice, nice, nice. And we can actually, because we're going to need this once again for the plus and minus, though we cannot just OR them here because otherwise they would have the same precedence. We actually have to do another layer of this, basically. So you'd have something like this, and then you would change this to plus, minus. But you get the point. This would be repeated again, which is not great. Let's actually abstract this into its own function. And let's remove all this junk right now. We don't need it anymore. We figured it out finally. So okay, cool. And binary operator just then unary operator dot repeated. Okay. Anyways, let's actually cut this and let's make a function. Let's make a subparser right now. I don't know what to call it. Maybe binary parser. Binary is cool. And let's just do this, I guess. And then we don't need to do this and just do this. And then we're just gonna basically return something similar to this. So okay, cool. Now we just need some few things here, some few arguments. We need the previous parser, I guess. Is that the case? I'm not sure what to call it, to be honest with you. But let's call it previous parser for now. And I wish I was able to actually make this into an alias instead of typing this again, but just write it until it's painful because you'll probably change it multiple times and maybe you would need to separate them. Yeah, no, I'm not actually doing any kind of over abstraction right now. It's just because I'm gonna repeat this. I'm gonna reuse this for sum and subtraction. That's why. But I'm not doing any magic abstractions. Don't worry. So okay. Okay, so use of moved value. Now, this is a problem that I struggled with as a beginner, but the actual fix was as simple as adding another bound to this impl parser thing. So you would just say, I wonder if copy would actually work here. Yeah, it actually works, I guess. Or is it? Yeah, I think it does. Interesting. Otherwise, if it doesn't, you could just make it clone instead, right? And then just clone it. So you would clone it here, right? So there you go. Yeah, we could just keep clone because it would accept more parsers. So yeah. So basically what I'm saying here is that previous parser should be a parser, right? But also it should be clonable. So because here we're gonna need it 2 times pretty much. We clone it the first time and the second time we just consume it pretty much. And yeah, right now we just need these 2 operators right here. Or actually, maybe we could turn this into a choice instead of an or. Let's see. Binary operator is equal to choice. And now we're just gonna need just this dot to expression, and we're gonna need it again. Okay. And is this the right place? No, it's here. It should be a tuple, you know. And there you go. And here just division, but of course this would be its own operator, I guess. So let's make some other arguments here. So let's say I suck at naming, but I guess I'll just go with operator 1, maybe. Okay. And we can just have maybe a char with its corresponding enum. But what we're gonna do? Well, I guess we could just go with expression, right? That's simple, I guess. And operator 2 finally. Well, it's gonna be the exact same thing. Char with an expression. Maybe. We'll see how it goes. And now we can hopefully say operator 1.0, operator 1.1. Well, interesting. I see. Actually, this should be a binary operator instead, and we don't need the as binary operator here. And there you go. There you go. Now the operator 2 here, .0. And if you don't know anything on what the heck I'm saying right now, just maybe watch my previous stream first. I have actually explained a lot of, not all of what I'm doing right now, but a lot of it to get into the mentality of understanding this. But anyways, oh crap, what the heck, lifetimes? Oh my god, I'm quitting, Ben. I don't want to deal with lifetimes right now. Okay, so what's up here? Be right back watching the last one. Alright. You can just watch right now with us for now. So if you have any questions, and then later after the stream you can rewatch, you know. Yeah. Feel free. Explicit lifetime requiring a type of operator 1 lifetime SRC required. What the heck is this talking about? I don't see any references. What lifetime? Oh, my bad. I see. So the binary operator actually takes a lifetime. My bad. Great. Okay, so we have done it. Great. So basically right now, you have seen how we can actually make a little sub parser. Right? So you can actually right now make some unit tests for this particular parser alone and test it independently. Magic. Yeah, exactly. It's magic. Pretty cool stuff. Okay, so let's try if this works actually. product is equal to binary parser, and the previous parser in this case is unary operator, and the operator one is oh yeah, it's gonna be a tuple, and the char first is multiplication, and the expression mole, right? Cool. Expression mole. And we don't even need right now as, you know, the as binary operator, because it would be done implicitly since it's in the signature of the function. So that's amazing. Divided by and expression divide. Let's go. There you go, it's happening. Okay, look at that beauty. I don't know, man. There's nothing more beautiful than this. Oh crap. Product is equal to binary parser, unary operator, multiplication, expression mole, division, expression div. I could have also maybe put it implemented the into trait for character on expression. But the problem with that, I can't. Because here I don't have the exact type information, right, of expression. I only have the binary operator down. What is it called? I don't know. Anyways, so I'm not sure how to go about that, but I may think about it. Anyways, so that's basically it for that. And what the heck is going on with you? Huh? The trait bound impulse Chomsky parser is not satisfied. Huh? Oh, I guess maybe I know what's going on here. The signature is going wild, but I think we probably want clone here. Is it? Yeah, probably. And we just gotta make sure to clone this here, because we're using it twice. Actually, yeah, there you go. Okay, cool. And I think this should work just like before, if I didn't lose my mind. There you go. Cool. Now, the next precedence operators would be very simple to implement. We're gonna say sum is equal to binary parser. The previous parser is product, and operator one is plus with expression add. And here we're just gonna copy the other one. I think you see where I'm going with this right now. Minus sub. There you go. Huh. Okay, what's up? Use of moved value product. Ah, I see. So we gotta make sure to clone this here. Oh crap. There you go. And let's go. That's what I'm talking about. Now, if everything goes into plan, we should be able to parse the plus operator too. Let's see. But let's spice this thing up a bit. Let's actually put this guy first. I don't know. It's cargo R. Oh crap. Called parse result in wrap, and the parse results contain errors. Found minus at 1415. Found minus at 1415. I mean, honestly, maybe we should implement some better error handling, because this suck. I think we could probably do that easily using another crate. And apparently that crate is also made by the same author of this crate. Okay, so there you go. Look at that beauty. I don't know how to actually get it to look like this. I tried it before, but it wasn't literally like this, but I'm sure there is a way to make it like this. I'm just dumb. Anyways, so there you go. This is the other crate. Ariadne, a fancy compiler diagnostics crate. Hopefully I didn't butcher the name, but there you go. There you go. I'm honestly not entirely sure how this crate works. It's very weird. And apparently there's also a lot of work on this one too happening. So, but yeah, there you go. Let's see if we can actually do this easily. If we can't, I'm just gonna give up on it for now until we revisit it later. But right now, honestly, we do need some better error handling, hopefully. Just a bit better. Anyways, so let's actually cargo add right now. --git. Paste the link of the GitHub repo. Because I'm using the master branch. Because, you know, the crates are going through a lot of updates currently. As you see, alpha. But anyways. So let's see if we can actually figure this out from the examples real quick. If we can't, we're gonna give up on it. And by the way, this thing here is the initial of my last name, which is interesting. It's apparently also this thing right here. What is it called? This one right here. Now you know why my logo contains that. Anyways, let's go to SimpleRS and let's see what we got here. Report build. Well, it's one of the reasons why my logo contains that. I just like the style of it, honestly, and I like the fact that it's, you know, white and black. It's like binary. I love binary. Either way, let's go back to what we have here. Report build. Okay, so here's the deal. If parsing didn't go well, instead of giving our user a middle finger, we're gonna try to give him some more beautiful errors. Let's see. I guess match AST maybe? Okay, how are we gonna do this? What this returns, bro? I think maybe okay, no? Right? Is it? And this would probably be the actual AST. And here, and let's just try to print line our AST. Beautiful debug printer for now. And is this correct? I don't think it is. Well, then maybe in wrap or not really. Can I make it into a result? Okay, there you go, into result. Great. Now I can actually do that match, because apparently it's a custom result type for some reason by default. Not sure why that's the case, but there you go. Now it's actually print line. Okay, AST. There you go. And yep, there you go. And now, if an error happens though, we're gonna get some beautiful errors in a vector. Cool. Now we gotta actually iterate through those errors. And for now though, we're only gonna get like very simple and only one error, because apparently to get some more robust and more interesting errors, you gotta go through some more complexity, which we're not gonna go into for now. But let's just go with for each anyways. So this is a vector. Let's make it into an iterator and consume in the vector, because we're not gonna need it anymore. And then let's iterate through all the errors that we have. And now we are getting that simple error that we specified in the parser signature. And now we gotta do what you gotta do. Source does not live long enough. Huh. I see. Because we don't have a semicolon here, so it escapes out of the main function, which is not great. Okay, cool. So now what? Okay, let's actually deal with this error right here. So I think we're gonna build a Ariadne report build, and here we need the kind. Report kind. Custom. I think error maybe, isn't it? Actually, it's called error like this. Okay. And source ID, apparently, I don't know what this means, to be honest with you. But let's just go like the example. The offset, I think let's go with the error, and we can get the span of where the error happened in the source code, and then we can get the start of it. Maybe. I don't understand this completely, but there you go. Report kind, failed to resolve. Come on, bro, import this. Okay, there you go. Cool. Now, well, I mean, let's just copy this, bro. Why I'm wasting my time right now? I have no clue. Okay, great. Let's see what we got. Here, error.spam.start. Let's just call it parse error. Or too boring. Let's go now with label. I think we're gonna have one label, because I honestly do not understand what the heck this library is about. Import source. Okay, and with label. Well, can't we? Anyways, let's go with this. And here we're gonna give it the span, the error span, and the with the message. Well, for message, error dot into maybe? Huh? No clue what the heck I'm doing. I don't think GitHub Copilot can help me with this. Source from includes sir. Well, we already got the source, right? There you go. Okay, so what's up? What's up next? I need some better example, please. Please. Multi-file, actually. What I'm missing, bro, is not satisfied. Really? Are you kidding me? Into range? Apparently that works. Am I supposed to figure this out myself? I'm pretty sure this was more simpler before. Type annotation cannot satisfy toString. Well, what about this? I guess. Alrighty. What's up now? Cannot move around, cannot move out of source. A captured value in an FNM mute. Closure occurs because source has type string, which is not. I see. But where it is exactly moved? Oh, because this is a for each loop. Well, that suck. That's what I hate about for each. I see. Because it moves the thing. So, well. We're gonna do a boring for loop. For error in errors into iter. And do this, I guess. Maybe this would fix our problems. Inside of this loop. What the heck? Maybe I should clone it anyways? Bruh. Let's go. What a good time to be alive. Okay. Seems like finally it's satisfied. And there you go. Let's go. That's what I call working smart. You use libraries. Amazing. Lovely. Lovely. Let's go. Found minus at 1415. Okay. So what is the problem exactly here? Maybe padded? Maybe we need padded. And oh, hold on. I think I know what's the problem. There you go. Got it. And okay, we got an AST. Does this work? Let's find out. So the first operation we're gonna do is the multiplication, not the add or the sub, the multiplication right here. There you go. So it works. The precedence also works, so that's lovely. And the division, then the division, right? And then the sub, and then finally the add operation. Perfect. Perfecto. Let's go. Okay, so what's next? What did I miss? Okay, so I want to add strings, and I also want to add function calls and also parentheses. I think honestly, let's go with parentheses if we can figure it out. Hopefully my brain didn't shut down just yet. Let's see. Alright. Where is the parentheses? I guess maybe it's not handled here. Probably not. We gotta scavenge for it somewhere else. Or maybe we could just do it ourselves. Anyways. I mean, honestly, let's try to do it ourselves first. Oh, my bad. I'm seeing my own code. But yeah, let's go back. Let's go. Is the stream still fine, by the way? Seems all good. Nice. All right. Great. Yeah, where is that? Hold on. Okay, there you go. So integer or expression delimited by just that or call or what the heck. Anyways, gotcha, I gotcha. Do not worry. So I think before the unary operator, because, you know, parentheses have more, what is it called? Precedence, right? So let's go ahead and do that. All right, where to even start with this? Good question. Let's I don't know what to call it. I'm gonna call it like what the example called it, I guess. So Adam is equal to what did it do again? integer or expression? So all of this is one recursive. Interesting. The or call or identifier.map xpr var. Okay, Adam xpr call identifier. Oh, actually what they're doing here, yeah, I see. So our atom is basically the value. Right? So number or identifier. Well, it's time to change up this a bit. Make it a choice instead to make this a little bit more cleaner, a little bit more hygiene. And let's go to the next one. So it would be either a number. So a value is either a number, identifier, or an expression. But the good question is where to get this expression. And apparently it seems like we gotta make this into a whole block. Yeah, pretty much, I guess. So okay, can I actually do this? XPR recursive, please don't suck. Recursive XPR. Okay. I don't know what to do with the let, to be honest, because it's also recursive. Oh crap. Well, for now, let's just ignore it, I guess, because I'm not sure how to go about that for now. And then let's just grab this for now. We're just gonna have a calculator for now, a glorified calculator. So trait bound Chomsky private parser sealer. What the heck is that? Oh. Okay, nice. So we return the sum. Should we return expression? What is let here? Okay, hold on. Where they put it let in this case? They put it here with the declarations. Yeah, let's ignore lets for now. And let's just go with this. Let's pick this somewhere around here for now. And okay, so what's up? There you go. Now, if I'm thinking this correctly, let's just remove the let temporarily for now. And let's test our calculator. Okay, so alright, so it still works, I guess. And now if we added, well, I mean, we haven't done anything interesting yet though. So XPR or, well, not or, delimited by. So we want them delimited by parentheses, I guess. And, what's up? Oh, just, there you go. There you go. Okay. But before that, let's actually say, I guess, separated by a, separated by what? Do we actually need that? I don't think. Good question. No, that's the call. But where they handle... There you go. XPR delimited by just. So we only need those, yeah. Makes sense. My brain crashed there. Cargo R. Let's see what we got. Let's see. And now, what happens if we do this? That was super fast. Well, because it's in runtime. Okay. So, did it work or not? Good question. So this add right here, yeah, it is happening first, right? And then we actually multiply with 1 over 23. Okay, we got parentheses. Let's go. Let's go. All right, nice, nice. Great. Well, I think I know how to actually approach this right now. So this is our expression, right? This whole thing is our expression, I guess. Right? So this is our expression. Oh crap, what the heck? And there you go. So here, basically, this is where the recursion happens. So cool. Cool. So basically, a value is either a number, identifier, or another recursive expression that is delimited by just this or that. Interesting. Okay, so we got an expression right now. Great. And I think now I know what to do with this already. Hopefully. Unless if I miscalculated, as I always do. Expression. Great. And now, if you actually do let hello is equal to that, would this work? And found, oh yeah, we need a semicolon there. Cool. All right, we're getting something. Let hello equal to subtraction number that div mul add, and we also of course have the unit operators that we handled before. That's pretty cool, isn't it? Do I actually handle this correctly though? Let me see, hold on. So where is this part in the ASC here? Where is it? There you go. So it is this one right here. So we're multiplying by the number 23. Huh. Okay, gotcha. Now, if we do minus 1 over 23, huh? Why I wasn't expecting that? Interesting. What if I do this? Okay. Did we get it? Yeah, I'm currently just doing it like this by multiplying by minus 1, pretty much. Okay, cool. Well, honestly, I'm thinking if we should actually use a separate AST variant, like negate. Yeah, maybe. Negate. So maybe we can add like a negate here. And so that means we would also avoid one box, you know, for that, I guess. Let's see. So negate. Let's see if I can figure this out. What did I write though? What is this? Okay. My brain I just hit the reset button accidentally. Pa-pa-da-pa-pa. What am I even doing here? Where we're handling the negation part. Yeah, in the unary operator. Let's go. Okay, so right now currently we're just making the expression multiply. Okay. Huh. Box new expression number A. So how are we gonna do this? Well. Expression number A. The thing is we're handling multiple operators here. So, I mean, to be honest with you, if it works, don't touch it. I'm too lazy for this. Let's see. Now, let's actually do some function calls, maybe? Where to even start with that? Good question. So we basically want something like this. But actually before that, well, yeah, pretty much. How are we gonna do it? Okay, let's see. So we're gonna have a call, and this would contain the function that we want to call, pretty much. I mean the name of the function that we want to call, and what else? We're also gonna have arguments, right? So we're gonna have vector of, well, recursionception. Box expression, src. There you go. Okay, I think that's all we need. To call a function, you just need the name of the function and a list of arguments, or a vector of arguments. Okay, cool. So, where are we gonna do this? Maybe we can do it somewhere around here. Expression delimited by just that or that number or identifier. So yeah, a function call would basically resolve to, a number or whatever, basically value, right? I guess. So maybe we can treat it as such. Okay, let's see how this goes. Call is equal to identifier. Call is equal to identifier. And yeah, I mean, because like the function name would be an identifier. And then we're going to maybe try to parse delimited by just that. Then expression. Oh, I think we could probably gonna need this somewhere around here, maybe. Actually, I do need the value. Yeah, I do. So maybe afterwards? Huh. Bruh. Well, hold on. My brain is confused right now. Well, I guess let's just go with it and see where we're gonna find ourselves. So identifier, then I would guess maybe value dot repeated, maybe dot delimited by, well, first of all, maybe separated, right? Separated by comma. Oh crap, what the heck. Then delimited by just parentheses, right? And well, of course we do need a just here too. Okay. I can surely smell my brain smoking. Value dot repeated dot oh crap. Separated by use of moved value. Okay. Clone it, I guess. But the thing is, to be honest, I'm quite confused. Let's see what we got here. Or maybe actually we probably gotta do it before. Yeah, maybe. Okay, what if we do it here then? Right? And instead of value, we do actually expression. Do we actually need to clone now? Yeah, we do. Okay. Dot repeated, then separate by just this and delimited by just that. And that's, ladies and gentlemen, a call parser, I guess. How did they do the call here? Identifier, yeah. Then expression clone separated by just. This is what I've done, right? Well, they did it before, but I'm not sure if that actually matters, to be honest with you. Maybe it does. So, okay. And they actually collected it first. Huh. And also they allow trailing. This is basically so we can do something like this, but also allow a trailing comma like this. So that's cool. Sure, I want that in my language. Separate by allow trailing and then repeated. Where is repeated? Oh, what? Maybe we don't need repeated. Maybe delimited by or separated by already does that. Yeah, probably separated by does that. Oh yeah, there you go. Any number of times. So we don't actually need repeated. Cool. So separated by that, allow trailing, and delimited by just that and that. Very readable. Let's go. As long as you don't look into the types. Okay. Cool. Let's see now what we got. We can, good question. Now, I'm kind of confused right now because I want the call to also be an expression, but the expression is also a call. Does that even make any sense? My brain is wrapping into some other dimension right now. Well, maybe we should actually do it here. Maybe. And then put it here. Oh, this doesn't look good. Sorry, what is going on here? Oh, I see. I think I know what's going on. We gotta map this into an expression. Well, I don't think it's that easy, is it? Separated by just, allow trailing. I mean, yeah, well, first of all, let's actually collect these. Let's collect these arguments. Collect into a vector. right? Oh, before the limited by. Okay, interesting. Okay. And then we could maybe map it into a call. Would that work directly? Good question. Function expected to take one argument, but it takes two arguments. Function expected to take, but takes two arguments. Function, what the heck is that error? Well, I guess the best we can do maybe is do something like this. Okay, so we actually got only a vec expression, but where is the actual identifier? Huh. Oh, my bad. I see. Or is it? Hold on. Oh yeah, I got you. I should do it here. And then maybe I could say expression call. Is it that easy? Well, maybe not. To take a single to tuple as argument, but it takes two distinct arguments. Well, okay, gotcha. Gotcha. So I should do it like this. I honestly quite hate, to be honest, functions with multiple arguments. I mean, can't we just make all functions take one argument, and then if you want multiple arguments, then you just pass a tuple, so it works well with functional programming all the time? Okay, let's go. So here, we're gonna go with the name of the function and the arguments of the function. There you go, cool. And now we could hopefully call the call with the name, and finally, hold on, why am boxing the expression? What the heck? I don't need to box it because I'm using a vec, which is already allocated on the heap. So maybe that's all I needed? Maybe not. Is it? What if I done this? No. No, it's not. Okay. What about now? What is the name? Oh crap, it is an expression. Huh. What? Ah, I see, because we're mapping it here. Gotcha. So let's just use this instead. Okay, there you go. I guess maybe we have done it. Let's try this out. Moment of truth. Found. I mean, that's how it's supposed to be. Okay, so we have the identifier. It parsed that, but it had a problem with this. Then an expression.clone. Expression clone. Is that actually correct? Huh. Separated by separated by just that, by a comma, allow trailing, collect into a vector, delimited by delimited by just that. So why that wouldn't work? Oh, did we actually include the call into? I see what's the problem with this. We have to actually include this here. My bad. Okay, let's try now. And same error. What the heck? Maybe it's a problem with the order of this? Possibly. There you go. We got something interesting going on here. So oh, I'm so excited. Okay, we got a call. The name is F, which is correct. Then we got an identifier X, identifier Y. Pretty cool. Can we allow trailing? Yes, we can. Hell yeah, let's go. Okay, so can we, do some recursion and include this whole thing there? We actually can. There you go. Done. All right, so we're parsing this, boys. We're parsing this. Let's go. Alrighty. Lovely. So we actually got function calls right now. We got the let. Now we're gonna need some how to declare functions. We also need strings too. We also need if conditions. Oh my god. We also need for loops. Crap. Well, I guess we're just starting out. Okay, cool. Cool. Is the stream still fine? Okay, I'm gonna take 5 minutes a break and then we can continue. Okay, back. Let's actually remove this. Alright, so, well, the first thing that I guess I want to do, I'm just going to make this into its own little parser. Because here what we're essentially parsing a tuple, right? So a function call is just an identifier that a tuple comes after it, I guess. At least that's how I think about it, maybe. Expression, clone, separated by just. Yeah, this is basically a tuple, pretty much. So then tuple right here. And we're gonna have let tuple is equal to this. And there you go. A call, it is a text identifier, then a tuple, dot map, blah blah blah. There you go. And now we could even do something crazy, which is a value could also be a tuple. It's that simple. It's called recycling, pretty much. But the only problem here is that we should make sure to map it, in this case, to an actual expression, I guess. Yeah, pretty much. But like, okay. Interesting. Well, there's two ways we can go about this. We can actually make this an expression instead of a vec. Maybe I'm just discovering Lisp right now, or what? Is this a trap? Okay. I don't know, man. Let's just do I guess the simplest thing for now. So tuple.map, and this is the no, what I'm doing. Well, we're just gonna add basically a tuple expression. So here, I'm gonna add a tuple expression. Yeah, honestly, I think the call would probably take a tuple instead. And so basically a tuple is just this, right? Yeah. The problem though, if I made this a tuple, then I would have to box it, right? And that suck. Because I'll have another allocation for no reason. Right. Can't I by any chance? Does it even make sense to tell it explicitly that it should be a tuple? I don't think so. Am I losing my mind? Yeah, of course not. Okay, so let's just keep it as it was, honestly. Let's not overthink it right now. And let's go. Pretty much. We can easily, I mean, if in the call, we could easily just, wrap this vec into a tuple. Easily, and just pass it directly, and there you go. As simple as that. Yeah. We can even make this a bit readable, maybe. By, I thought it was programming C++. Okay. So let's say type args, maybe. Would this make it a little bit nicer? By any chance? Well, how do you even type, like, forward declaring Rust? Is it even possible? Oh, actually you don't have to in Rust. Yeah. Great. I thought I was programming in a language from the 80s, or I don't know where, when. But there you go. Rust actually don't even need forward declaration in the first place. It just happens, Love this. I absolutely love this. There you go. Okay, let's go. There you go. Nice, nice, nice. So map A. Okay, so these are the arguments. Hold on, is it the arg? Yeah, okay. And then, yeah, we could basically map it into an expression tuple. Yeah, pretty much, I guess. Okay, what's happening right now? Use of moved. Ah, I see. Clone this. And there you go. It's that simple. Okay. So now we can actually even have something crazy like plus, I don't know, let's say print, I guess, and then a tuple 1 2 3 maybe. And let's go. Call print. The arguments is one argument, which is a tuple. One argument. Okay. And there you go. Number 1, number 2, number 3. That is lovely. And of course, we can actually make multiple let expressions after the other, and let's go. And let the magic happens. There you go. Amazing. Okay. Okay. At some point I thought maybe I left the microphone off. Oh my god. My heart skipped a beat there. Okay. Is the stream still fine, by the way? Let me make sure. Okay, seems good to me. Is there any dropped frames? No? Great. Okay, let's continue, I guess. Alright, so now what to add next? Do some XP optimization. Tunify Basic, welcome to live stream. Yeah, we could do that later on. Right now, I'm not really focusing much about optimization, and I'm just trying to get this to work. I'm just trying to focus on the parsing alone. Then later on, we can focus on maybe evaluation first, honestly, and then after that, maybe optimization. So yeah, we'll see about that. I'll see. Okay, so I think right now what I'd like to add maybe is declaring functions. Any GitHub? Yeah, I did. I did publish it to GitHub. Let's go. Feel free to commit, like to contribute or whatever. That would be great. And if anyone commits something, then we're just gonna review it in the next stream. If it aligns with the direction of this, then sure, we're gonna merge it. If not, sorry. But there you go. Okay, I'm the first one to start my repo, I guess. Let's go. I did put it in on Discord, so just make sure if you're not already on Discord, I put the link there, and I also notify people about live streams. Anyways, but pretty much I try to live stream every day currently on on midnight GMT time zone, right? So pretty much. So let's go. Okay, let's continue. So right now I want to do maybe some function declarations. Now I'm honestly not sure about this, how we're gonna go about it. But one thing that I know for sure, I want functions in my language to be first class values. Just like how it's done in Lua, right? Because I honestly do not understand why languages even make a separate, you know, declaration thing for functions. I mean, bro, I want my functions to be just like this. Let add is equal to, and then here you just put some lambda or whichever. As simple as that. But where to go with this next, I'm not sure. In Lua, which is the first language that I've learned, you do it like this. So instead of let, you would just have local, but you got the point, right? And you'd have function a comma b, and then you would return a plus b. You would do it like this in Lua. But for sure, I don't want to spell function. I want to go with fn like Rust, first of all. And the second of all, I don't like end. And I don't think I like return either. Maybe something like this? Or maybe we could do it like Rust and try to maybe do it like this. Huh. I'm not sure if we can even do this. And if it's not ambiguous with the other syntax we have. A, B. But the thing is, as I said, I don't like separate arguments, honestly. And since I don't like, if you want multiple arguments to a function, you know, just use a tuple. Isn't it the case? Okay. Not sure. But how that would work? You would maybe say fn. And then you would say, I guess, I don't think that's beautiful. I mean, even if I go with that, I would probably just leave it anyways. But then you would need to pass it to... Honestly, you know what? Let's just leave it as it is for now. As you would do it normally. And then later on I can think about it. But we'll see. Anyways, so maybe let's try to do this. So of course we already have let right now. We just need to figure out this one right here. So yeah. So of course a function would be a value. So that's what I mean by first class citizen. So yeah, I guess let's try it. So first of all, we're gonna have a pipe. So it's basically delimited by pipe, right? So here we have a arguments or tuple, kinda, and then finally the implementation, which is gonna be an expression, I think. Okay, let's see what we could do here. So this would be, well, let's just call it a closure anyways. Is equal to, so we already have tuple, but it is using this parentheses though. I mean, we can do it. We can do it like this then maybe, right? But would that not be, would that, hold on a second. I think that would be ambiguous, honestly. Yeah, that would probably not work. That would probably not work. Because like in our language you can have tuples, right? And this could be parsed as a comma b as a value, right? And then a plus b. Yeah, I don't think that would work. So I guess we're just gonna have to do it again, but with these. Well, as long as maybe I, well, let's try this one, honestly. Let's try this one. So closure. Let's just remove it from now because it's gonna pollute my thing with errors right now. Don't want that. Okay, cool. So now I think I'm just gonna start with the tuple thing here. Let's just copy and paste right now. and separated by, yeah, exactly. Well, honestly, we can probably just go with the space even. No, never mind. Let's just go with this. Allow trailing collect, delimited by just this and that. There you go. Okay. So we parse this first, and then what? And then expression. Right? Where is expression? Oh yeah, there you go. Would this work? No clue. You have to clone it because it got moved. There you go. Okay, I think this would work, maybe. But let's find out. It's the only way to find out. Closure. And what are we gonna have here? We're gonna have here arguments, right? So basically args src, and we're gonna have yeah, expression pretty much. Box expression. Well, in fact, this is not arguments. This is parameters if you want to be technical about it, but who cares? I mean, hold on a second. Actually, yeah, that's true. So that's wrong. It's good that I'm technical. Okay. Yeah, actually, like arguments is not like parameters, you know. They're way different. So arguments, it's a vector of expressions, but parameters is a vector of identifiers. So it would be something like this, right? Pretty much. There you go. I'm glad I figured that out already. I mean, I would have figured it out eventually anyways. But, well, anyways. Box expression. src here. And there you go. Let's go. Parameters, box expression. Now the real question is, would this actually work? Okay. Let's try, I guess. What? Oh, there you go. Okay. I see. So let's actually make sure to map this into... Can we just map it directly to an expression closure? Probably not, since we have to box the expression, right? Yeah, then expression.clone, I see. So let's make it closure. And here we're gonna have our parameters, right? Or params. And we're gonna have what is it called? Expression, yeah. Okay, is this correct? It's not giving me the types for some reason. Weird. Anyways, let's go with expression closure. And here we're gonna have the parameters. Here we're gonna have the expression. Isn't it? Okay, there you go. So here we have a vic. What? It's already boxed? Maybe not. Maybe I'm missing out here. Weird. I don't think so. Maybe I have to actually box it here. And let's see. So what's up now? Closure is expected to take. Ah, I see. Already see. Okay. Gotcha. Let's go. There you go. Now what's up with the parameters? Ah, alright. Gotcha. So instead of expression, we actually want identifier. but without the map though. Yeah, just like this, right? So, yep, exactly. So there you go. I think this should work. Let's see. Parse error, okay. Found A. What? Maybe the order is effed up. Okay. Found A at Well, I mean, I actually removed this closure from the AST, so what's up now? Well, let's remove these for now. Okay, nice. So I don't know what happened there exactly, but yeah. And oh, I see. We need to pad these so spaces doesn't matter. Allow trailing separated. So let's say dot padded here. And let add is equal to a closure with the parameters A and B, and the body of that closure is add identifier A with B. Let's go. All right, great. Am I dreaming right now? This works from the first try. Interesting. Bro, when I'm gonna wake up right now? Let's go. We got closures working already. Interesting. I can't believe it was that easy. I'm probably missing something. Can't be this easy. Huh. Interesting. Well, what happens if I try to call? I guess the same functions again? Some recursion going on? Okay, yeah, I mean, nothing is wrong with that, AST. Nice. Let's go. Great. Okay. We got closures. Lovely. Alright, so what's next? What's next now? Well, maybe we need some control flow right now to spice things up a bit. How are we gonna go with that? Let's see. What should we start with? Okay. Maybe we can go with the condition first. I guess. Maybe we don't actually need it. Well, let's go, I guess. I'd like to honestly go with some sort of a functional approach here. So let's try to think about it. So like basically, let's say you're gonna get some inputs, right? Maybe some numbers is equal to I'd honestly would love to go with the Rusty way of doing things with the range, and that would be great. Huh. For each, no? Can we map it? Yeah. and then it would be great to, let's say, map input, I guess. Okay, so what we're gonna need here to add to our parser. First of all, we're gonna need to be able to parse ranges, syntax like this. The other thing that I see is we need the field kind of operator here. Or not field, but what this should be called. It doesn't have a name. I just don't remember the name. Anyways. And yeah, and this is just like a function call basically. We just need this right now and the range. Okay, so let's start with the range, I guess, because I love ranges. At least Rust ranges. And these are actually optional. So like you could do something like this and it would be inbounded from two sides. So cool. So let's say we're gonna have a range here. Okay, and what that range would contain? Well, it would contain a minimum and a maximum, and both are options. Both are optional, right? Cool. So this would be an option. Well, option of what? Option of, I guess, an expression, isn't it? I mean, I guess I would like to do something like this, maybe? Is that even possible? I mean, is that possible in Rust? First of all, I have no clue, to be honest with you. Let me see. Of course, this is possible in Rust, right? But what if I do something like this? Oh yeah, it is possible. And can I use variables too? Okay, yeah, I can. So yeah, expressions basically. Makes sense. So a range is basically an option of a... Do I need the box here? I do think so, yeah. Because option doesn't allocate though on the heap, so... Yeah, pretty much, maybe? Or am I mistaken? Huh. Oh yeah, there you go. So I do need a box here. So this is the first bound. This is the minimum, right? And finally, again, the maximum. So this is basically a bound. Type bound is equal to... Just making it a bit more readable, I guess. And there you go. But to be honest, should the option be there? Yeah, pretty much. Okay, cool. Cool. And there you go. That's a range. Right now, let's actually parse that bad boy. Let's go. So where to even start with that? So we got a tuple here. Yeah, it is delimited by that, and it is separated by 1 of this. Okay. Well, let's copy paste tuple again. Okay. And then we have expression separated by just this. Allow trailing, no way. And we only want to accept 2 arguments. Accept, pretty much. So, but this any number of times. So we got a limited though. At least or at most. I'm gonna say exactly 2. Okay. And instead of collecting a vec, we don't need to allocate for this. We already know the length. So we can collect exactly. And we can collect into an array. Right? No allocations needed because we already know the length at compile time. So, and how are we gonna do this? let's just do something here, I guess. Or can we just do this? Okay, cool, nice. So this array would contain 2 elements. So that's cool. The limited by just this and that, that is true, right? And there you go. Cool. Now, what's up with this? Oh, crap, I see. So this is a range parser. Okay, but hold on a second. I didn't make them optional. So separated by just, so expression clone dot optional, or what is it called? Yeah, or not, to make it optional. So expression or not separated by just this exactly 2 times and collect exactly into an array of 2 elements, delimited by just this and that. Isn't that magic? Man, that's so readable. Oh my god. Okay, cool. Let's see if this works. So I don't know which order I'm gonna go with this here, but let's just give it a shot, I guess. And yeah, I forgot one thing. Yeah, let's map this into an expression. I'm probably gonna need this. So like this would be the minimum and that would be the maximum, I guess. Is that right? Expression range min max. Yeah, there you go. This is an option of a box expression and this is an option of a box expression. But no, it's actually not. These are just expressions. So box new. Hold on a second. What? No. Well, the option is first, right? Yes, it is. So what we should actually do instead, we should map it, right? So if we don't have a bound there, we're not going to allocate, right? We don't need an allocation. We're just going to say none. But if we do have an expression there, then we're going to actually allocate that box. So map, I don't know what to call it. Let's call it X, I guess. And box, well, actually, I don't even need to do this. I could just say box new. There you go. That's pretty much it. Oh my god, I'm so in love with this. Ah, I see. So we actually gonna get an array, not a tuple. My bad, I see. Gotcha. Okay, so how are we gonna do this? Let's call it bounce, yeah? And there you go, it's an array. So now we can actually do this. Bounce. Can't I capture an array too? I don't think I can. Anyways, let's just do it like this for now. Cannot move. Huh. Out of type option. Do I need a reference here? What? Cannot move out of type option. Expression and non-copy array. Huh. Can I actually destructure it like this or something? I don't know. Is that even... Oh, crap. It is possible. I guess. What? Are you sure about that? No way. I'm so in love with Rust. Let's go. Nice. Alright, great. That is super beautiful. Okay, great. So let's try and see if this actually works or not in the first place. Okay, we have already included range into value. Let's see. Let's start simple for now. Cargo R. Okay, so we got a let numbers equal to a range, some number 0 to some number 10. If you don't include the bound, there you go, you get none here. If you don't include this bound, you get none. Okay, it works, I guess. Now we need the next thing is the dot operator. I mean, that's also an operator, right? And yeah, I think it is a binary operator, right? I mean, there's two things here. There's this guy and there's this guy. Yeah, pretty much. I think so. I'm not sure what you call it. Is it called just dot operator? Because I do think there was a name for it, maybe. Or maybe the axis operator? Okay. Well, I guess it just called the dot operator pretty much. I don't know. Anyways. So, well, what about the precedence though? What about the precedence? How that would work? Good question. No clue. I guess it have a higher precedence. I mean, I guess let's find out. And by the way, let's actually make sure that this works, for example. I don't know. Let's say something like this, I guess. And what? Hold on a second. Something is weird here. So this works, yeah? Add number 1 plus 2. That's the first bound. And yeah, we have something interesting here. We have a tuple instead of parentheses. But how would you know if you have a tuple or parentheses? Good question. How to disambiguate between them? I'm pretty sure I've seen that problem in Python. I'm pretty sure. First and foremost, tuples use parentheses instead of square brackets to define their elements. Huh? No. Yeah, okay. Another key difference is that they're immutable. Cannot be changed. That doesn't tell me anything, bro. Can tuples be written? When are parentheses required around the tuple? The combined fixed expression, the common token is turned. The rules of operator precedence do not. This is because expressionless are not themselves expressions. What the heck? They become expressions when enclosed in parentheses. What? I honestly have no clue. I didn't program in Python for a while now. But I think Python have a similar problem. How would you disambiguate between a tuple and a parentheses? Either way, maybe for now at least, what we... Oh, yeah, I remember now. I remember now. Let's go. Okay, I see. Well, what we just have to do here just make sure that the tuple comes after the parentheses. And how would you disambiguate in Python between a tuple of one element and parentheses? Is a tuple of one element would be something like this. Or I guess they use var in Python. Yeah, I remember now. You have to actually put a trailing comma to disambiguate between them. So this would be a tuple, right? Without this, this would be parentheses. So this is how you disambiguate between a tuple and parentheses, like a single element tuple and the parentheses in Python. And I think we're gonna do something similar. But yeah, now the problem that we have here is that we have the precedence of the tuple over the parentheses. Okay, interesting. What if we do this? Would this fix it by any chance? Hopefully I wouldn't screw something else. But I think it worked. Yeah, it did. There you go. There you go. Yep, let's go. It works. Nice. Amazing. So, okay, but what if we have something like this? So this becomes a tuple. Okay, without this, this would be a normal number. Perfect. Let's go. Okay, cool. Cool. Alrighty. This is how it's nice to know multiple languages. So when you create your own language, you just remember problems of another language and how it fixed it. The thing is, I already had the fix, I just need to know how. There you go. Anyways, so the key is a trailing comma. There you go, cool. Okay, so we have ranges right now. Let's actually also implement right now the dot operator. Okay. So for the dot operator, let's see. It's basically just this, right? Pretty much. And I think it would have bigger precedence, maybe. So, but would he have bigger precedence over the unary operator? Yeah, I think so. Yeah. Maybe. Let's see. So let dot operator is equal to oopsies is equal to, and I guess we're just gonna copy paste this again. Now choice, yeah, we're not gonna need this. Just say just a dot. It's too simple. Or is it? Hold on. Yeah, it is. And then we have dot repeated. I mean, yeah, we do want to repeat it because you do want something. Let's say, for example, something like this, a dot b dot c, you know, instead of just a dot b and that's it. Ah, interesting. So I got one more feature for free. Okay, cool. Folder. Do we want to fold right or left? Good question. Well, I guess we're just gonna try out. Okay, cool. Let's go ahead. But hold on. I actually copied the unary operator. My bad. I'm a stupid. Anyways. Let's actually grab a binary parser. Oh. The problem, my binary parser is hard-coded to have two operators in it. Interesting. Interesting. Can we actually fix that? Hold on a second. I mean, this doesn't have to be like this. Okay, so maybe we can receive maybe an, well, not an iterator. Maybe generic array? Crap. To be honest with you, I'm just gonna copy this for now. And we can figure it out later. Let's see. Product. So before our product, and in fact even before our unary operator, we're gonna have that. So we don't need a choice here. We don't have a choice. Just dot. That's as simple as that. So this is our dot operator. But like, actually, hold on. Yeah, just inline it pretty much. Binary operator like that. The previous parser is value, I guess. Clone fold L, just a dot. Then previous parser again. Dot repeated. I honestly still don't understand how this works, but it works. Okay, so here instead of OP, we're just gonna hard code it to expression dot. Is that the case? Okay, what's up with this guy? Value moved. Okay, I see. So let's clone this. And there you go. I think that's pretty much it, actually. And we don't need the operator in this case. So we can as well ignore it. And that means we're not going to need this anymore. Well, there you go. Amazing. Let's go. Okay, let's see if this actually works or not, or I'm just dreaming here. But hold on, what the... Okay, I need to actually set this to a dot operator is equal to that. And now instead of value here, hold on. Yeah, pretty much. We're gonna go with the dot operator instead, I think. Or is it? Yeah, I think so. Let's try this out and find out. I probably didn't save, yeah. Yeah, I didn't save. Okay, let's save and cargo R. And okay, is this correct? So identifier. So first we access B from A, right? So and then we access B. Well, we access C from B. Yeah, I think that's correct. So you access B, then C. I think we have done it pretty much. This is crazy, man. Let's go. That is crazy. I wonder though if we can actually optimize this just a bit. Nothing fancy. Maybe, you know, like treat it, instead of treating it as a binary operator. But no, the nice, I mean, we could just like treat it kind of like separated by a dot. The problem though with that, is there actually a problem with that? Hold on. What is going to be the difference between treating this as a binary operator like we're doing right now? or just, you know, kind of treating it like an array or a list and just separated by dots? Good question. I don't think you could well, do you even need that? Like, I think you could technically do this, right? Yeah, pretty much. But is that any useful? I don't think so. Yeah, that's not useful at all. Yeah, I see. B dot C. Huh. Yeah, I'm questioning my existence right now. Okay, A dot B dot C. Yeah, I don't think that's legal. Unless if we go crazy like C++ and make everything overloadable, I guess. Can you actually do that in C++? I don't know. Hold on a second. Let's just ask, I guess, GitHub Copilot. Let's see what it says. Let's ask AI. See what it says. Is the dot operator a binary operator? Yes, the dot operator is a binary operator in main programming language that is used to access properties or methods. The object on the left side, the operator and the property. Please provide more. However, the code snippet you provide seems to be syntax that is not common in popular programming. Hold on a second. Well, does this have any meaning in any programming language? The syntax is not common in most popular programming languages. However, in some languages like OCaml, the dot operator can be used in this way for dynamic field access. Ooh, I never actually learned OCaml. Alright, would mean accessing the bth element of array A. What the heck are you even talking about? Would mean accessing the bth element. Huh? What? What is even that? However, the b.c part is not typical for array indices, which are usually integers. Without more context or information about the specific language, it's hard to provide definitive interpretation. Well, our language is definite. Hold on. Well, let's say you have something like, I don't know, but what if you have something like, is that even... Well, that would mean that we're not gonna need special syntax, I guess, for arrays then. For array access. Crazy. But probably people would hate me for this syntax for array access. I honestly do not know, man. But like what I'm thinking about, another way that we could do this basically is, instead of this, we could just go directly and do it like this, I guess. Unless if I'm not thinking straight right now. Value. Is it yeah. So, separated. But in fact, we don't even need the value. If we really just want to go the traditional way, then we can just say text identifier. But like our language is maybe dynamic, isn't it? So if we do it this way, then you may be able to do something like, I don't know, something like hello world. That is wild. I don't approve of this, but like it is possible, I guess. Man, I'm on another dimension right now. Okay, let's see. But I mean, let's try this other way of doing it too. Why not? Well, instead of fold, what we're gonna basically do, separate it by just dot. I don't think we want to allow trailing. Separate by a dot and collect, I guess. Collect, yeah. Delimited by no need, and yeah, just collect. Field access. The only problem with this that I see is the fact that right now, instead of just, you know, kind of like, actually, hold on, no. The thing is about this expression dot, we're allocating twice actually for every operand. But here we're only going to be allocating one vector, you know. So one big allocation instead of a bunch of allocations. To be honest, I'm going to keep this, and we're probably just going to use this way for now. Though, if anyone have any ideas, please let me know. I'm not entirely sure. Like, I've never made the language before. I'm just winging it right now, I guess. Collect into what? I guess into a vec, yeah. And let's go. Collect into a vec. And now, instead of box expression and stuff like that. Huh. Okay. And now we can just say vec. But yeah, hold on a second. This is just parameters? I mean, yes and no, but dot product takes parameters. Let's just keep it like this for now. All right, and then what? Where's that thing? I'm surely losing my mind in a good way right now. Okay. Dot map into an expression. Dot. Okay. There you go. All right, let's try this one. Ouch. Let's make sure we don't have any finicky thing, I guess. There you go. So now instead of having that binary stuff like that, we just have a dot with this, with a vector. So that's cool. That's cool. Pretty cool. So can we actually do right now that syntax that everyone was talking about? That is the real question. Okay, moment of truth. Okay, found that at 14:15. We probably have something that have to do with precedence, maybe. And range, closure. I honestly do not know how to actually debug this, to be honest with you. Range, closure, call, number identifier. Huh. Well, I mean, it should be parsing a range here. Hold on a second. I probably have made some weird thing right now. Oh, actually, do I need this? What? Interesting. What the heck? What did I mess up? Well, hold on. What did I just add right now? Oh, the dot operator, right? Well, what if I remove that? Is it messing up with my thing? It is. Yep, it is messing with my thing. So what's up? My logic is wrong somehow. What if I use this first version that I had before? Probably missing something here. Oh crap, what I've done. Hold on. What? Ah, I see. Well, let's do this. This box and what was it again? Fixture box. Box what? Oh, I think it's. Huh? Do we even need that? Man. Expression. Yeah, I probably modeled it on the binary operators pretty much, yeah. Let's try this out. Okay, so I guess with this what? Why? Interesting. Yeah, probably missing something, but I guess this works. Anyways, let's try this out. And that seems to actually work. Which is crazy. Okay, let's see if this AST is right. So we got let numbers equal to dot of this range right here. Right, so this is the one that we access with a call, and then finally the end, right, of the program. So we call map with hold on a second, no, this is the call, right? So is it okay? Map closure. So the name of the function is map that we're calling, and they have one argument x, and the expression that this function calculates is basically multiplying the identifier x with number 2. Now the real question is, could we actually do let? I don't think we can, because this is an expression, and I don't think expression includes the let keyword. Yeah, this is where the Rust block syntax comes in, I guess. Interesting. Yeah, I don't think that would work, right? I mean, I guess let's try it. Who cares? Let's see. I don't think it works. Of course not, yeah. There you go. I mean, that makes all sense. Because here we need an expression, and let is not an expression. Yeah? Yeah, pretty much, yeah. Okay. Well, where's our call? Well, not call, but function? Where is that? Closure, yeah. It is inside of expression. Do we actually need the inside expression? We're using it once here. But yeah, we're actually including inside the value, so we do need it here, yeah. Okay. So we probably need some new syntax for a block, just like Rust. Yeah, I think so. If it's not an expression, you need to make a block. Okay, so... But then, how would you actually do a block? Because we do not have access to let here. We only have access to expression. Good question. No clue, honestly. Maybe we're gonna need a, you know, when a problem seems wrong, we probably need, like when a problem becomes hard or even impossible, maybe we need another indirection by separating possibly the lexer from the parser. I could be just saying nonsense though. So yeah. Okay, anyways, what should we do next now? I honestly, I don't think I even need if conditions right now and for loops. I mean, I could just do this, I guess. Right? But yeah, I'm still missing the actual statements inside of that, which kind of suck. Huh. That is interesting. I think we can think about it later. If you guys have any suggestions or something like that, please let me know. That is very interesting. So yeah, I honestly think this should be enough for today. It's been 2.5 hours. That was a lot of fun. Oh my god. That was a lot of fun. That is wild. Well, I'm gonna commit this. And if you guys want to work on this further or give your comments on this, please be at home. You're my guest. Just, you know, make a issue or make a pull request. Well, no. Yeah, pretty much. And we can see you together in the next stream. And yeah, I think that was it for this live stream. So this is the second stream. And yep, let's commit this. Or actually, let's just make this a bit more nicer, more interesting, I guess. So x times 2. What else did we add today? Closures, and we also added, what we added too. Okay, so of course we implemented the operators. Call, oh crap, I see. Alrighty, but we're already using call here. What's we're not using right now? Yeah, the only thing that we're not using right now is tuple, I think. Well, other than the other operators, but we don't care about that. Let's identify. Yeah, pretty much only tuples we're not using here. Okay. Can we actually use it somehow meaningfully here? I don't know. Anyways, fine for now. Let's just finish this up. Let's commit this, sync changes, and there you go. Let's go. That was a lot of fun. Just making sure everything is fine. And yeah, that was it for this stream. And see ya later. Bye, everyone.